In this video, I will introduce the idea of symmetry, odd and even functions, and then for part 2, we'll talk more about graphs and some other aspects. So a function is even if it's symmetric with respect to the y-axis. If the point AB is on the graph of an even function, the point negative AB, or opposite A we can think of, must also be on the graph. Using function notation, f is an even function if f of negative A equals f of A for all A in the domain of f. So here we have a blank graph. I'm going to draw a parabola in there, just using our parent function. I'll just do that really quick with you. So for f of x equals x squared, that's what I'm looking at. The basic shape, you would start at the origin. If x is 0, if we made a quick table, or we just know the basic shape. Negative 1 squared is 1. 1 squared is also 1. Negative 2 squared is positive 4. 2 squared is also positive 4. So that's your basic shape right here. So get used to just kind of graphing those in, sketching those in really quickly. You can kind of notice this little pattern here, like you kind of go up and over 1 and then up 3 over 1 as your average rate of change there. So here's the function, and we notice that, say for instance, this point here, we have 2, 4, because I'm squaring every time this negative 2, I'm also going to get an output of 4. So that's why the evens work. And they reflect over, if you see here, that's my y-axis. If that were a mirror or a piece of paper and I folded it, like kind of like those ink blot butterflies that maybe you used to make when you were younger, that is the idea. So if we have an A and then we have opposite A on the other side of the y-axis, that'll give us the same output. And the same thing here, we have 1, and negative 1, 1, and then 0, 0. That's just our kind of middle point there. So in our vertex. So if we want to look at this function notation here, we can check it. Like this is how I would check. I would say, okay, what's f of x, or a in this case? So I'm going to say, what's f of, let's just pick 3. F of 3 would be 3 squared, which equals 9, right? Now I'm going to look at f of negative 3. Because I'm trying to see, like, are those going to be equivalent? And then I would plug in negative 3 squared, and that also equals 9. So yes, it's even, right? My function is even. You might say, well, it has an even exponent. That kind of gives you a clue. Yes, in this one, that's really helpful, and you can just look at it and know, but they are going to have some other things that are more involved, so I want you to have a good method to follow. So that's it for evens. Let's take a look at odds now. So a function is odd if it's symmetric with respect to the origin, which is right here. So this one's a little bit trickier. We're going to do a cubic function to show you, but it's really like you're taking whatever's here and you flip it, but then you kind of flip again. So you're doing this 180-degree rotation. So I'll show you what that looks like. And we will quick plot our cubic function. Again, just get used to kind of knowing the point. So we're going to do f of x equals x cubed. This is my f of x here. Should always label those. And that's x. There's some numbers in there already for you. So 0, 0 obviously works. 1 cubed would also be 1. 2 cubed would be 8. So that's going to kind of go way up here. So 1, 2, 3, 4, 5, 6, 7, 8. We can kind of just judge. So I'm just going to put a light dot there. On the other side, -1 cubed would give me actually -1. So there's kind of a clue that it's flipping around. And then we have -2 would give me the -8. So let's say that's -5, 6, 7, 8, right about there. So I'm going to sketch this cube again. And after a while, you just get the basic shape. Hopefully you've seen that video on the parent functions or library functions, function toolkit. So it's just this little bend that you typically get right there. Okay. It's kind of made that all really thick. So once we get those, let's look at the points. The point AB, if the point AB is on the graph of an odd function, the point -A, -B. So not only does the X value change to its opposite, so does the Y. That's why you're having like this flip and flip again. So it's kind of around the origin here. So that must also be on the graph using function notation. F is an odd function if f of -A equals -f of A outside. So if I have the negative of my A, and that's going to equal negative of f of A for all A in the domain. So we'll look at that algebraically, but let's first look at the graph and how the points relate to one another. We're going to look at this piece here. So you don't have to jot down points, but a lot of times that helps. So we'll have 1, 1 we know is on the graph. We have 0, 0. And if 1, 1's on the graph, we notice here, yes, -1, -1 is also on the graph. So that's what we're looking at up here. If you want to look at the algebraic process, then we would just again pop in how this works. So we would have f of, if I want to pick, let's pick the -2. Okay, f of -2. Let's see what that comes out to be. If I put -2 in and cube it, I get -8. Now let's try the other way around here. So we're going to put in negative f of negative or regular 2, positive 2, and see what that comes out to be. So I would have negative, I'm just going to really differentiate that's outside of the output there at first, and then we would have 2 cubed, and that also equals -8. So therefore, it's an odd function. So this you'll need maybe a little bit of practice with. Usually you can eyeball it on a graph, but again, sometimes it's just hard to tell. So proving it out algebraically like this is really helpful. And sometimes the graphs are tricky. Sometimes we don't even give you a function, just give you a picture to try. The next thing we want to look at is when a function can be symmetric with respect to y equals x, and that's this line of symmetry here. Okay, if I have -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, so y is just always equal to x, and that's what our inverses are symmetric about. So we want to just take a look at a graph like that. So our fold line this time is this red dash, y equals x. I just kind of sketched that in there. And then I'm just going to sketch a little piece here. Okay, so for this one, I'm using f of x equals 1 over x. I did put the table here just because sometimes that's a little trickier for people to figure out on this one. Not used to it as much, but this is just our basic rational, and you can see where it will reflect. So if I have 1 as my A and my B, so I have 1, 1, then switching them around to be 1, 1, I mean, that's kind of obvious. It's just the same point there. It's right on the fold line. And then if I had 1/3, 3, you notice that the switch of that, 3, 1/3, is also on the graph, and you can clearly see that in the table, but I also drew it here. Now, we never touch the axis because we can't have 0 in a denominator. So that's actually what we call our vertical asymptote at x equals 0. And then we also have a horizontal asymptote here at y equals 0. And we'll learn more about those later on in the curriculum, the details of more complicated rationals and how to graph them when there's a bunch of stuff going on. But this is just the basic shape for that one. And what if we had a negative? Let's just check that out. So if we have -1 and we put that under 1, we would also have -1. So that's right there on the other side. And then we also have, so this is kind of an interesting one. We have, let's just do -1/3. And then we would plug that in and we would get -3. And so you can kind of guess here. Let's see, my x is -1/3. What the other one's going to be, right? It's going to be over here at 3, or -3, -1/3. So this one's even more special. It reflects over the origin also. So I hope that helps you get used to this idea of even and odd, and a little bit about symmetry in respect to the y equals x. So we'll look more into that in part 2 of the worksheet. So that'll be a separate video. I'm putting these in playlists now, so they're clumped together. So if one gets lost in popping it up, make sure you look for that on YouTube in the playlist. Thanks for watching. Have a great day.